Hello. Yeah, this video is the Cox proportional hazard regression model part 2. In this video, I want to show you how to do a few additional analysis for a fitted Cox model. So they're listed here. Type 3 analysis, comparing models using LRT, like the ratio test. Smooth terms, extract the AIC value, estimating the baseline cumulative hazard function, goodness fit statistic and test, testing the proportional hazard assumption, and plotting the estimated survival function. Okay. So first, let's reading the data. And these are first few rows. And then to demonstrate the type 3 analysis, I need a categorical predictor with more than 2 categories. So I will categorize DBP into 7 categories here. All right, so next let's loading library survival and just first I want to add the DBP cat into the data frame, and then I noted there are missing values in the data frame, so I get rid of those missing values, and then I fit this model with the predictors as shown there. And here's the summary of the model. So because the DBP cat has more than 2 categories, so in the coefficient table, they're listed there, but the p-values here are from the Wald test for pairwise comparison of each category listed here comparing to the reference category. So this does not answer the question overall if DBP cat is significantly associated with survival time. So for that, we can perform the so-called type 3 analysis. This is very similar to what we do in logistic regression. Remember that? Just we are in the Cox model is so-called semi-parametric model. You get a baseline hazard function multiplied to the e to the power of beta x, right? So for the parametric part, the e to the beta x part, we can treat it similarly like a GLM. So we can use the type 3 analysis here. The command is ANOVA, then Cox model object, and test equal to chi-squared. You can see now it shows all these predictors are significant, and the DBP cat, even though it has many categories, here you just have one p-value. Okay, next one is comparing models using LRT. I know these are nested models. So first, let's try another model. This is the same model except we do not include the BMI. So Cox model 2 fitted here. And then we can use ANOVA, Cox model 2, and Cox model, and test equal to LRT, or test equal to chi-squared to give the same result. You can see the output here. It has model 1 and model 2, and model 2 has an additional BMI variable there. So model 1 is nested within model 2, and you see the p-value is very small. So that means adding BMI significantly improved model fit. Next is the smooth terms. So this is used when we think the effect of a predictor going into the model should be in a nonlinear fashion instead of the linear fashion, as specified by the Cox model. For example, in this model, if we think age is nonlinear, should be entered into the model nonlinearly, maybe there's a, I don't know, curvilinear relationship of age with survival time. So we can use, so here we use the p-spline, so piecewise spline. This will give us like a data-driven piecewise spline curve fitting. So this if it can capture nonlinear patterns if they exist. So we select the degree equal to 4, degree of freedom equal to 4. So let's fit that model, Cox model 3, and this is the output. And we can plot the relationship between age and so here we can see this relationship between age and the dependent variable, even though it has some curvilinear there, but very slightly. Overall, it still looks like a straight line, right? Anyway, next topic is extract the AIC value. As we know, AIC value is very convenient for comparing models, especially non-nested models. So here it's very easy to do. Just use the function extract AIC. So here we extract AIC for Cox model 2 and Cox model 3. And remember, Cox model 2 is nested Cox model. The Cox model 3, even though it has age, same variables as Cox model, but age here is entered as a nonlinear term. So you can see the AIC value is printed here. So you can see the AIC for Cox model is 22,795.45. The AIC for the Cox model 3 is 22,796.4726. So adding a very expensive piecewise supplying to the model for age doesn't really change the AIC value much. Okay. Next one is so we can actually estimate the baseline hazard function. Actually, it will compute the cumulative hazard function using the function base has. And this is the syntax. You can look at the dimension and structure of BH. It's a data frame with 2 variables. And you can simply plot out this cumulative hazard function in the baseline. Another topic is the goodness of fit. Statistical Cox model. You can get that from library serve MISC. You can just directly call the function GOF. And you can see what it does is you have your original model, then it has another model with adding some called index G, and to test if this larger model and the smaller model are exactly the same. So basically here, it's just saying p-value is 0.6176, so there's no difference. So the model fit is okay. But a warning is Cox model is very delicate, so you should not just rely on this one GOF function to judge the goodness fit. It's just one aspect. So additional check for pH assumptions or residual analysis are needed, especially when you have something like the time vary covariance. Okay, the next one is for testing the pH assumption. We know the pH assumption is critical for Cox model, so this must be done for every Cox model we fit. Okay? It's very convenient in R. We just use from cox.zph, and syntax is very simple here. You get the object test pH, so you can see it gives you this table for the chi-square statistic degree of freedom and p-value, and looks like except for BMI, all the other variables are not really following the proportional hazard assumption. So globally, it's not, so we have to do something about it. If you want to have some visualization, you can use this syntax plot, test the pH, then you can specify 2, 3, 4, 5. It will give you the plot for that term. So for this one, it's the second term is sex. So they give you this plot showing you this the beta xt here. And for the 3, that's the SCL. And yeah, as in the sex variable is a categorical, it's a binary, so you got 2 separate clusters of data points here. So SCL is continuous, so it's there, and you can see the curve as like hidden inside those data clouds. Next one is for plotting the estimate survival function. You can use the surf fit to fit a Kaplan-Meier curve using off the fitted Cox model object, and then just plot it out. This gives you the estimated survival function with a confidence band around it. And you can have something fancier by using the serve minor library. And you can use the GG serve plot function. Give you this more colorful graph. Okay. Yeah, I have not covered 3 topics: delayed entry, time varying covariates, and residual analysis. Those are very complicated topics, so I will cover them one by one using individual videos. Thank you.